Hi everyone. So today we're going to be starting with a pretty simple optimization problem. It reads as follows: the sum of two positive numbers is 16. What is the smallest possible value of the sum of their squares? So first thing we notice is sum. That's telling us that it's going to require addition. Two positive numbers, let's just say we have x and y greater than or equal to 0. And we're looking for the smallest possible value of the sum of their squares. Smallest is going to give us the biggest clue that we are minimizing. With optimization problems, we are either minimizing or maximizing, and in this case, we're minimizing. So we're going to need to write two equations. We're going to take the first piece of information and, so to say, convert it into math terms. So the sum of two positive numbers, we have x plus y is equal to 16. And that's just coming from this piece of information right here. Next, we're looking for the smallest possible value of the sum of their squares. So that means that we're going to have a separate equation, x squared plus y squared is going to equal some problem, let's just call it a. And that's what we want to minimize, aka that's what we want to take the derivative of. So what we need to do before we take the derivative of it is we're going to have two equations. One of them is just going to be a piece of information, and that piece of information we're going to substitute into our second equation and then take the derivative of it. It's kind of like when you ask your friends what they're interested in eating, you want to take their consideration. So when we make our decision, aka minimize, we want to take this piece of information into consideration. So we first need to substitute it in. First thing we got to do to substitute it in is solve for one variable. Doesn't matter whether it's x or y, we're going to get the same answer in the end. I should clarify, not the exact same answer for each number, but you're going to end up with the overall same answer for either x or y. So in this case, we have y is equal to 16 minus x. And I just did that by subtracting x on both sides. X minus x cancels itself out. Okay. Now we're going to take this piece of information and we're going to plug it into here. Oh, wow, my hands are shaking. Yeah, I'm definitely a little nervous. But I'm hoping that me helping you with math makes you less nervous. Okay, so now we have x squared plus 16 minus x squared is equal to a. We're going to go ahead and take the derivative of it. I'm going to start writing the a on the left side. It technically shouldn't make a difference, but I'm just writing a prime is going to be equal to 2x. For that, we are using the power rule, moving the 2 to the front. 2 minus 1 equals 1. We have an invisible secret little 1 up here. Next, we're going to be taking the derivative of the second part, which we're going to be using both the power rule and the, chain rule. So we start with the outside, do the same thing that we did with this x. We take the 2, bring it down to the front. 2 minus 1 is equal to 1, and invisible little 1. So we have plus 2, 16 minus x, invisible little 1 on top, and now we're going to use the chain rule to take the derivative of the inside. The derivative of 16 is going to be 0, but the derivative of negative x, or subtract x, is going to be negative 1. So we're going to multiply that by negative 1. I'm going to go ahead and rewrite this. Go ahead and zoom in a little bit. So now that we've taken the derivative, we want to go ahead and simplify before we set it equal to x. We have 2x plus 32 minus 2x. That's just me distributing. And we still have this times negative 1. So now I'm going to distribute the negative 1 over. That's going to give me 2x minus 32 plus 2x equals 4x minus 32. All right, so this is all a prime. Now, since we want to minimize, whenever we have a local minima or a local maxima on a graph, the derivative at that point is going to equal 0, right? So that's why we want to set this equal to 0. So now we have 0 equals 4x minus 32. We're going to go ahead and solve for x. Plus 32 plus 32. 32 is equal to 4x. Divide by 4, divide by 4, and we have x is equal to 8. Okay, beautiful, we're done. Actually, no. So we need to find the smallest possible value of the sum of their squares. So we're going to use our piece of information beforehand to say that if we know x is equal to 8, we're going to have 8 plus y is equal to 16. So what does that give us? Minus 8, minus 8. We get that y is equal to 8. You're like, oh, technically, couldn't it be, actually, no, it couldn't be any other possible number in this case. Sometimes you come up with a few other possible answers, and then you go back to your initial conditions to check them, but in this case, this is the only possible answer. So we get that x is equal to 8, and we get that y is equal to 8, and so now we need to find the value of the sum of their squares. So we get 8 squared plus y squared. Oops, we know y is 8. And so that's going to be 64 plus 64, which is going to be, ironically, I'm not great at doing math in my head. That's 120 plus 8, so 128, which is our final answer. Hopefully that made sense. Feel free to go ahead and like this video, save it. I'm definitely going to be doing a whole series on different optimization problems. I make sure to do the even ones from textbooks just because I know those are the ones that don't have the answers in the back. So hopefully this will be helpful for those missing problems.